Hello. Today we're going to look at angle theorems for triangles, and you have this foldable here. And so if you'll lift up this first page, we've got some vocabulary on this page that we need to be familiar with. So we have first what says interior angles. And so interior, the word interior means inside. So if you know of a person that is an interior decorator, they decorate the inside of a home. So interior angles in a triangle are the three angles that are on the inside. Exterior angles, exterior means outside. So the exterior of your house might be brick, it might be siding, or it could be something else altogether. So exterior means on the outside. So outside angles on a triangle are the ones not inside. They're outside the triangle. And then we have remote interior angles. So a remote is used on a TV from far away. We don't go right up to the TV and point our remote at it to change the channels. We are sitting on the couch, so we can change the channels from the couch. So far away, but interior still means inside. So what it's referring to is here we've got an exterior angle or an outside angle. But the far away inside angles, remote, far away, interior, inside. And that's it. That's all there is. So not this guy right here, because he's right beside it. He's not far away. Not this inside angle, but the two that are far away. That's remote interior. So looking at this right here, this triangle. Interior angles are going to be angles 1, 2, and 3. Exterior angles are going to be 4. And the remote interior would be the ones that are far away. So that'd be angles 1 and 2 are remote interior to angle 4. So turn the page. We're going to be looking at the triangle sum theorem. And this works for every triangle ever. No matter how large, no matter how small, no matter if it's right, acute, obtuse, or scaling, isosceles, and equilateral. Any of those kinds of triangles. Every triangle ever. This works. So I'm going to introduce you to some geometry language here. So when you see this language, this is what it means. M is going to be referring to the measure. And this little symbol that kind of looks like a less than symbol is actually talking about angle. So it's geometry shorthand for the measure of angle. So the measure of angle A plus the measure of angle B plus the measure of angle C in every triangle ever, 180 degrees. So let's look at number 1. This is how you're going to be asked about this. We have two angles, angles X and angles Z, are marked as 77 degrees and 54 degrees. So there's two ways you could approach it. You could say 77 plus 54, that's 11, that's 131. So we got 131 degrees in this triangle. I know in every triangle ever I have a total of 180 degrees. So I'm going to take this 131 and subtract it from 180. That's 9 and that's 4. So this measure of angle Y is 49 degrees. That was the missing angle. Another way to do it, take care of business in one quick expression, would be 180 minus parentheses 77 plus 54 and equal. So order of operation says do parentheses first. This is still 131 and you've got a 180 minus 131. That's still going to be 49 degrees. So the measure of angle Y, we could say the measure of angle Y, that's not a Y, is 49 degrees. Number 2, same process. So I'm going to do it like this because this is faster for me. If you like this way, then you do that way. So 180 degrees minus the 2 that I already know will tell me the missing measure of angle F. So I add together what I already have and subtract it from 180 to find out the measure of angle F. So together, this much right here is 141. So that's 180 minus 141. That leaves me 39 degrees is left for the measure of angle F. So if we wanted to write it out, we can say the measure of angle F is 39 degrees. Number 3 gets a little more complicated because it's throwing in some algebra with it. But we still know that in every triangle ever, we have a sum of 180 degrees between those 3 angles. I'm going to use that to my advantage. So angle S is 7x. Angle T is the expression 4x plus 5. Angle U is the expression 6x plus 5. So that's a big long expression right there. But every triangle ever, those 3 angles all together make 180 degrees. What I do from here is say I'm going to combine like terms. And pay attention to the operation in front of each term. I have 7x plus 4x plus 16x is 17x. 5 and 5 are like terms and they go together. Constants. That's 180 degrees. Now I have a 2-step equation. First, I'm going to eliminate my constant, 10, by, instead of adding 10, I'm going to get rid of it by subtracting 10. That makes a 0 pair. I got to do the same thing in both sides to keep it balanced, to keep my equation balanced. So 180 minus 10 is 170. I'm going to bring down my 17x equals 170. The operation that's occurring here is multiplication, so I use the inverse of multiplication, which is to divide. 17 divided by 17 makes 1x, and 170 divided by 17 is equal to 10. So depending upon your question, if it says find x, so angle S, I'm going to start right here. X was 10. So my expression for angle S is 7x. So I'm going to substitute 10 in for x, and I have found now that the measure of angle S is 70 degrees. I'm going to switch colors. So the measure of angle T, I'm going to pull it up here to the top of the paper. 4x plus 5. I'm going to substitute 10 in for the x with parentheses, because that means 4 times 10, which is 40. 40 plus 5 is 45. So the measure of angle T is 45 degrees. The last one, angle U, the expression is 6x plus 5. I'm going to substitute 10 for x. 6 times 10 is 60, plus 5 is 65. 65 is the measure of angle U. Now I'm going to check and make sure this actually works, because every triangle ever, the sum of all the angles is 180 degrees. So I'm going to take 70 plus 45 plus 65. I'm going to add it all together. This is my check. Am I right? 5 and 5 is 10. Carry. 1 and 7 is 8. Plus 4 is 12. Plus 6 is 180. I did it right. I got it. I'm going to leave number 4 for you guys to try that all by yourselves. Thanks for listening.